Okay. Just give me a minute. This is the page. So let's start with this first problem of today's that is bit play. I'm audible, right? Yes, no. And my voice is not breaking, right? Okay, it's clear for everyone. So let me know if in case you feel like my voice is breaking, or in case like my screen start to like freeze, or you feel like it's a bit laggy. So let me know at that very instance. So anyway, let's start with this problem. So this is the first problem of today's step 2. In this problem, we're given that Shafina has a binary string S of odd length n, and she has also a operation string O of length n minus 1 by 2. So OI is either an AND operation or an OR operation or an XOR operation. So see, the following conditions are satisfied with respect to strings. So for this, S3 will be some operation like O1 operation, S1 and S2. Then this for S3 and S4, we'll apply this O2 operation and we'll get S5. So we'll keep doing this till Sn, and we have to find how many operation strings O satisfies all these conditions. And we have to find it modulo 10 to the power 9 plus 7. So the only thing in that problem that like you can get it wrong is this thing. Like we're first checking for S1, S2 and getting S3. Then we're not doing S2, S3 and getting S4. We're directly jumping on S3, S4 and getting S5. So once this thing is clear to you, how we can solve this problem? See, we have some string S. So for these two, just check how many ways. See, there are only AND, OR, and XOR operation, right? So if there are only these operations, you can check for all of these, like whether S1 and S2 is equals to S3. If it is, like let's say you have an variable X, initially it's 0, X will be 1, like just increment your X by 1. Then if S1 or S2 is equals to S3, then again, this is also an option. Like initially this was just an option. So increment your X also by 1. And if S1 XOR S2 is equals to S3, then again increment your X by 1. So finally, X will give you how many valid options do you have for S1 and S2, like in order to make these equals to S3, how many options there are, or like options for operations. So finally, you can multiply your answer with this X and take modulo. Is it clear? Yes, no? Is it clear? Yes, no, anything? Because finally, like how many like strings are possible? See, if there are, see, you have the string size is 2, operations string size is 2. For the first place, you have 3 options, and the second place you have 2 options. So the total number of strings that are possible is 6. So that's why we are multiplying. Is it okay? Let me show you the implementation. So this is the implementation. In this, I'm first taking n as input, then I'm taking string s as input. So initially my answer is 1, then I'm starting from 0, and while I plus 2 is less than or equals to n minus 1, so that is the last index. And like I said, you have to do I plus equals to 2, not plus plus, because like we are skipping we are skipping S2 and S3. We are not doing S2 and operation S3 is equals to S4. So we are skipping all those even places. So like S2 and S3, we are skipping those places, not even places. So, but basically for each, I have this X as 0, and then I'm calculating like this is just the number, whether it's 0 or 1. So these are those 3 numbers, A, B, and C. Then I'm applying operation on these. If this is indeed equals to C, then I'll add 1 to X. So similarly for other 2 options, I'll add 1 to X. Finally, I'll multiply my answer with this X. And finally, I can print it. So if this is clear, I'll move to the next problem. Okay, so let's go to the next problem. So this is the next problem. In this problem, we are given that we have an array A of n integers, like n distinct integers, and k is either 0 or 1. And our task is to find the total number of permutations of array A such that all pairs I and j, I is less than equals to I is less than j, and I plus j being odd number, ai plus aj modulo 2 should be equals to k. Now k is either 0 or 1, and we have to find all the permutations of array A modulo 10 to the power 9 plus 7. So how many people were able to solve this problem? Okay. Anyway, see. First of all, what does this mean that I plus j is odd? Can anyone tell me? What does that mean? I plus j is odd. So, yes, then, okay, yes. Basically, it means if I is even, then j is odd. So, I plus j is odd simply means that both are of different parity. Is it making sense or no? Like, by different parity, I simply mean that if I is odd, then j must be even. If I is even, then j must be odd. So now let's first solve the problem for k is equals to 0. So what is given to us that ai plus aj modulo 2 should be equals to k. Yes, no, this is what we have to do, right? So in this case, ai and aj must have same ai and aj must have same parity. Must have same parity. So if they must have same parity, now if they must have same parity, now initially I'm like considering the case when k is equals to 0, right? So this means that ai and aj must have same parity. So let's say a0, that is the first number, is, let's not take a0, let's take a1, because like that is how I and j are given to us. So a1 is even. So if a1 is even, a3, not a3, a2, because I plus j is odd, right? So I is, if I is odd, j must be even. J must be even. So a2, a4, a6, all of these must be also even. Yes, no? Is it making sense? So if this is making sense, then what about a3? Can anyone tell me what should a3 be? See, for if we, this was because of a1, by looking at a1. If I follow the same approach for a2, a3, a5, and all of these should be also even. If a1 is even. Similarly, if a1 is odd, then all of these should be also odd. So for k is equals to 0 case, we can just check if all the numbers are not like even or odd. If all the numbers are even or odd, then we can like arrange them in any order. So can someone tell me how many ways are there to arrange these n numbers? Like in any manner? Is it? It is n factorial, right? N factorial. And if like we don't have all the numbers as even or odd, like we have a mixture of these, then in that case our answer will be simply 0. Now coming to another case when we have k as 1. So now if a1 is odd, then a3, a4, like a2, a4, a5, all of these should be of, like they should be even. And looking at this, a3, a5, a7 should be even, like should be odd, same as a1. So now we can see if n is even, then we should have equal number of odd and even numbers, right? We should have equal number of odd and even numbers. And like we can arrange them in any manner. Like the positions are fixed. Like either odd numbers will take all the even indices or they will take odd indices. And like then like we have once we have fixed all the odd numbers, then even numbers will eventually get fixed. But there are how many ways are that we can arrange these numbers? Factorial of odd. Like that is how many ways we can arrange these odd numbers. See, eventually, let's say I have decided that all the odd numbers will go at even indices. So odd number 1 will come here, odd number 2 will come here, odd number 3 will come here. Now there are three ways to arrange these three numbers itself, right? So that's why it will be factorial of 3, that is factorial of odd into factorial of even. Yes, no, is it making sense? Like these are the number of ways to arrange these odd numbers among themselves. And now since even and odd both are same, like I can either have odd numbers at even indices or I can have odd numbers at odd indices. So eventually this is twice. Is it making sense? Yes, no. So this is nothing but 2 times factorial of n by 2 square. In case when n is even and odd is equals to even, like number of odd elements and number of even elements in array are same. If it is not same, then the answer is 0. Is it making sense? When k is 1 and n is even. Yes, no. Okay, why answer is 0? Because see, if odd is not equals to even, eventually every odd index should have even element, and every if every even this odd indices should have like same parity elements, and every even index element should have same parity elements. So they should be equal, right? N by 2, n by 2. Yes, no. Like it is not 0. I'm not saying if for n, I'm just saying that if n is even, then this is for n is even. Complete cases for n is even. If odd is equals to even, then answer is this. And if n is even and odd is not equals to even, then answer is 0. I'm not talking about when n is odd. I have not taken that into consideration right now. I'm just saying when n is even. N is even and odd is not equals to even. Like let's say you have n as 4. So you have 4 places and you have 3 odd elements and 1 even. So how will you fill these elements? There should be like 2 odd and 2 even. Then you could have simply like odd, odd, even, even, right? But if you have 3 odd, then you'll have no possible way to satisfy the condition given in this problem statement. That's why if n is even and odd is not equals to even, then answer is 0. Answer is 0. Now there is only one case left when n is odd. So if n is odd, then one of your like either odd must be equals to even plus 1 or even should be equals to odd plus 1. So now we cannot have like 2 times, but still the answer will be factorial of odd. Like number of ways you can arrange these into number of ways you can arrange these. Like since now you cannot have something like why we were having a multiplication by 2 earlier, because we could have odd at even places or we could have odd at odd places, like in any of those. But now it is fixed. If odd is equals to even plus 1, 3, 4, 5. Now n is odd, like n is 5. So if odd is equals to even plus 1, now odd will always come at these places and even will always come at these places. So you can only arrange these even elements at these places. So that's why it's factorial of even into factorial of odd. Now there is no 2 here. Is it clear? What about others? Is it clear? Yes, no? So we have covered all the cases when k was first, when k is 0, then when k is 1. There are cases like if n is even, then if n is odd. So let me show you the implementation. So first, I have taken n and k as input, then I've taken array a as input. Now this is the mod. These are the factorial values. Now starting like these, this is just factorial calculation. Now this is the number of even numbers and this is the number of odd numbers in my array. So after calculating this, first when k is 1, so if even is more than odd, I can just swap this. Okay, first of all, let's take that if k is 0. If k is 0, like I said, if k is 0, either of these should be equals to n. If either of these is equals to n, we can just output factorial n, otherwise it's 0. Now if k is 1, I'm always making e as my o as my bigger one. Like if e is more than o, I'll swap these two. Now here I can assume that o is more. So first of all, the cases when e and o are both same. If e and o are both same, my answer is nothing but 2 times factorial of e into factorial of o. This is same as 2 times factorial of n by 2 into factorial of n by 2, because e and o are both same. So this is when e and o are both same. Now I have already assumed that e plus 1 will be equals to, like, o is always more, right? So I'm just checking for if o is equals to e plus 1. I'm not checking for other thing, that e is equals to o plus 1. Why? Because here I'm making sure that o is the one which is bigger. So in this case, if e plus 1 is equals to o, then my answer will be answer times factorial of e into factorial of o, and I can print my answer. There will be not 2 times this thing. Here it was 2 times. Is it clear? Yes, no? Okay, so let's go to the next problem. Okay, this is not it. So this is the next. So in this, I have an even integer n and an integer k, and we need to generate an array A of size n such that AI is between 10 to the power 5, 1 and 10 to the power 5. And for all I between 1 to n, the number of odd elements in the array is same as the even elements. And the sum of elements of the array is k. So this is a very simple problem. Just this thing, like you need to consider this thing. Otherwise, this is a very simple problem. How? Let me explain. See, you should have n is even. You should have exactly n by 2 odd elements and n by 2 even elements, right? Yes, no? Okay. So now tell me, there are some even elements, like there are some n by 2 odd elements, n by 2, and there are some even elements. So you cannot change parity of these, but see, this is odd element. Can I not make it 1? And what is the difference between 1 and this odd element? It will be something like even only, right? So the difference between 1 and this odd element will be even. It can be 0 also. So same thing between this and this, this and this, this and this, 2 and this. The difference between all of these will be some even. So let's accumulate everything at once. So that even thing I can add to any number. Yes, no? That even thing, just even thing, right? But I cannot just directly blindly add it to one number, because if I just like this 1 1 1 1 1 2 2 2 2 2, so I cannot, if I add that even thing to anywhere, like the parity won't change. The parity of odd will remain odd, for even it will remain even. But if I add it blindly, it's possible that this number will become more than 10 to the power 5. I cannot have more than 10 to the power 5 in any case. So that's why I just have to add it smartly. How? See, k can go up till 10 to the power 6. First, I'll try to make an array of exactly like this. Like half of my elements will be 1 and half of my elements will be 2. Now, there is something that I have to still add. What is it? It is nothing but k minus sum of my this array. Like let's call this is my array. So sum of this array. Okay. So now this is what I have to, this is remaining. So I'll try to add like this thing here, but I'll make sure 2 things. Like after adding, this thing doesn't exceed 10 to the power 5. And also I'm always adding even, like I'm always adding even some like even thing to this. I'm not adding odd, because if I'll add odd, then my answer, like the parity will change. If the parity changes, then like the whole solution fails. So that's why I'll always try to add even. In case after doing this, like I'm not getting the sum of this array as k, then answer doesn't exist. I can simply print -1 in that case. Is it clear? Is the whole approach clear? Like if that thing was not there, that a of I must be less than equals to 5, then you could have like a of 5 should be less than equals to 10 to the power 5. Then the solution would have been simple. This is remaining, just with the remaining percentage 2 is equals to 0. And if it is 0, just add this remaining to any of the element. It won't change parity. But you just had to check that remaining percentage 2 is 0 and also remaining is more than equals to 0. Like if in case your sum of this thing is already more than k, then answer doesn't exist. So in that case, if this thing didn't existed, then we just needed to check the remaining is even and the remaining is more than equals to 0. But now we also need to check that we are able to add this remaining to each of these elements, making sure that none of the elements exist, like none of the elements exist that are more than equals to 10 to the power 5, and still we are getting the sum as k. So let me show you the implementation. Okay, is my voice lagging for everyone or is it just lagging for some people? Okay, what about my screen? Okay, yeah, it's visible, but is it lagging? Yeah, I think it's because of the Wi-Fi connection. So let me continue for some moment, but if it is like, if it becomes unbearable, let me know. So this is the solution. In this, I first taken n and k as input. Then I have created a vector v, and in this, like elements are from 1 to n by 2. First half elements are 1, then the next half elements are 2. Now the sum is nothing but it is k minus and sum of this thing. So this is the thing that I have to add. So like first we can check if this thing is less than 0 or if this is odd, the answer doesn't exist. Otherwise, for each of these elements, this is the thing that I have to further add, right? So I make a temporary variable add and I'll assign this to it. Now I can add maximum of this thing. So I'll take minimum of 10 to the power 5 minus e. E is nothing but the current element. So this thing or this thing. So minimum of these will be added such that, like, why I'm doing this, so that my current element doesn't exceed 10 to the power 5. After this, if my add is even, like it is okay. But if add is odd, I cannot add it directly. Why? Because the parity will change of the current element. I don't want to change the parity. If it was odd, it should remain odd. If it was even, it should remain even. So that's why I'll decrease add minus add percentage 2. This will make sure that add is now even. Finally, I can add e to my, like, add this add thing to my current like current element and subtract it from s. S is the final thing that I had to add, right? So finally, I can check whether the sum, if the sum is currently equals to k. I have already made sure that the half of my elements are even and half are odd. So I just need to check whether or not the sum is equals to k or not. If it is, then I can print this vector v. This is printing vector, okay? And this is, otherwise I can print -1. Is it clear? Okay, so let's go to the next problem. Okay, so in this case, like in this problem, we are given that there are n bulbs, like and there's a bulb and n switches. The bulb will only light up if the n switches are in specific order, as given in the binary string s of size n. In this binary string, 0 at the ith position represents that the ith switch is off, and 1 means that it is on. Now, initially, Ceph has switches in a state represented by another binary string, which is t of length n. Now we want to make this string t same as string n, but we can do only this operation twice. So what is this operation? We can choose a substring in our string t L2R, and we can flip all the switches in that substring. So by flipping means that we'll change 0 to 1 and 1 to 0. So finally, we have to find how many sequence of these two operations exist such that we'll get the answer. So first of all, is my voice right now, is it breaking? Yes, no? How many people are currently facing the issue that my voice is breaking for them? What about others? Okay, anyway. First of all, in this problem, if we have some 0, 1, 0, 0, 1, 0, and we have another string like 1, 0, 0, 0, 0, 1. So like this doesn't match, this doesn't match, this doesn't match, and this doesn't match. So basically, I'm saying that this substring doesn't match, this substring doesn't match. So this is kind of like, let's consider these as a bad substring or bad segments. So in one operation, you can only at max get rid of one bad segment. Why? See, if you perform an operation from here to here completely, you can get rid of this segment, you can get rid of this segment, but this segment will appear. So in one operation, only one bad segment, like the number of bad segments will only get decreased by one. So instead of writing it like this, I should have written number of bad segments will be decreased by one at max. Okay, so now basically the thing is, if we have number of bad segments more than 2, the answer is no. We cannot get. Are you getting my point? Like in that case, the solution doesn't exist. Yes, no, anything? Because there are only 2 operations that you can do, and in one operation the number of bad segments will only decrease by 1. That's why if there are more than 2 bad segments, the answer is like 0, not like in this case it will be 0. So now how to solve this problem? In order to solve this problem, my voice is not breaking, right? First of all, otherwise I'll change my network. If okay, just give me a minute. So now if bad segments are more than 2, the answer is no. It is okay. How to solve the problem now? See, if there are no bad segments, first of all, if there are no bad segments, what we can do, we can select any segment in our first operation, and just undo what you just did, because the initial 2 strings were already matching. So you can select any segment in the first operation, and then in the second operation just undo what you have just did. So in this case, how many ways are there to select a segment? Can anyone tell me? Like how many ways, if you have a n length string, how many ways there exist such that you can select I and j, such that I is less than equals to j? Can anyone tell me? What are the number of operations? Like what are the number of, it's not n square, it n into n plus 1 by 2. For first, you have n valid operation. If this is your starting point, you have n operation, like n thing, n valid positions and n valid ending positions. And if you are at this place, you have n minus 1. If you are at this place, n minus 2, all the way up till 1. Okay, I think my internet speed just dropped. Am I audible? Let me change my network. Am I audible? Yes, no. I don't know why I'm facing this many issues. So if you are at last position, it's 1. Like if you're starting from any of these places, these are the number of options that you have for ending, like your ending place for the segment. So if you add all of these, you will get n into n plus 1 by 2, not n square. Okay. So now this is when you had no bad segment. Now, what if you have one bad segment? Can anyone tell me what will happen in that case? There is this, and let's say from here to here, you have a bad segment. See, in one operation, we can, first of all, there are 3 cases. The first one is we can reduce a part of this. We can reduce this part, and in next operation, you can take up this thing. Yes, no, right? So in first operation, you can make this part not bad, like flip this part, and in next operation, you can flip the other half. So, or in first operation, you can flip this part, and in next operation, you can flip this part. So for any I in this, you have basically 2 options. Why? First option is like you have two sequences. How? The first sequence is take the prefix and then take the suffix, or the second option is first take the suffix and then take the prefix. So every I between this bad segment. Is that okay? You have 2 options, right? To make this bad segment, like how is it in the string that you want. But what about the positions that are outside this bad segment? That is this part. So here also, see, I can, if I choose this as my first option, now this complete segment is bad. So in next operation, I can completely select this and make it good. Yes, no, anything, right? For this, I also, there is one option like this. There's also one more option. I can select this thing completely like this in first operation. Now, this was already bad, so it will become like equal to the string that I want, but this will become bad, this thing. So now in second operation, I can just select this thing and make it also like same as that I want it in my second string. So for this, there are 2 options, like 2 sequences. So for each I, you can consider, like if you start from here, for each of these I's, there are 2 sequences. For here also, there are 2 sequences, like same. Either you can first select this and then select this, or you can first select, maybe like for each I, you can first select this and then select this. So for each I, there are 2 operations. How many I's are there? There are n I's. So in this case, there will be 2 into n as our answer. Is it making sense? Yes, no? Is it clear? What about others? Is it clear? How did I get this 2n? If still anyone is having any doubt, I'll repeat myself. Probably you, like, if somebody missed something because of the internet fluctuation or anything. Okay, so let's go ahead. Now we have covered the case when there were no bad segment, 0 bad segments, 1 bad segment. And now let's cover the case when there are 2 bad segments. So how will we solve this? Now, like I said, one way is, like, let me write the ways. So the first option is this thing. Select the complete segment in first operation. And then what will you do in second? So this is not one of the ways. One of the ways is to first select up till this. The second operation is this. So this is the first way to do this. The second way to do this is start from here, end here. Second is from here to here. The third one, these are actually, this is first operation, this is second operation, this is first operation, this is second operation. The third operation will be something same. The third operation will be, okay, think I have done this wrong. This is because if you do like this, there will be a segment here which will remain bad. This part will remain bad, right? So that's why this is wrong. So let me write this again. So what I meant was, first part is this complete, and the second part will be this. Okay, yes, no, this will make sense. Now this will be not bad, this will be not bad, and this will also be not bad. Now the third will be, can anyone tell me what can third be? Third will be, anyone? I have done the whole, right? There is one thing. First the whole, no. Don't try to switch these. Can anyone tell, try to think. I'll just give you 20 more seconds and then I'll tell you. No. First operation is this, second operation is this. Is it making sense? This range came once. This range basically came once. This part came twice. So basically it is what it was earlier. And this came once. So we have also flipped this. So now I can always take now see, I can take vice versa of these. Instead of taking 1, 2 in this order, I can first take this as 1 and this as 2. Similarly here, I can take this as 1, this as 2. Similarly here, I can take this as 1 and this as 2. So there are total 6 possible options if I have 2 different segments, two different bad segments. So in that case, there are only these 6 as answer and nothing else. Is it clear? What about others? Is it clear or not clear? Is it clear to everyone? Okay. So let's go to the solution. So here I first taken string s and t as input. Now actually we don't have to calculate any of this. I just calculated it during the contest, but we don't need this. We just want how many segments are there, bad segment. So that can simply be done if s of I is not equals to t of I. Just keep incrementing your I while these are not equal, and you have got your one segment. Otherwise, if they are equal, just keep incrementing your I. So I think I have removed that thing also. So this thing. Okay. Now you just have to check if segment is 1, then your answer will be nothing but 2 times. This is nothing but the thing that I've written is n only. See why? Because see, I'm eventually multiplying by 2 here and here also. First is here. I'm subtracting it, I'm adding it here. Last is getting subtracted here. Eventually this is nothing but n. And we can print it. Otherwise, if segment is equals to 0, then the answer is nothing but n into n plus 1 by 2. This is just 1 LL. And this says if segment is more than 2, then answer is 0. If segment, the last case is if segment is 2, then the answer is 6. Is it clear? What about others? Is it clear? Yes, no? Actually, this is not, this will be n minus 1, not n. Why? Why this will be not? See, here it is first, last is added here, last is subtracted here. So we are left with n minus 1, not. I'll explain this in a moment. Just give me a second. This is n minus 1. See, where is that part? Here. For everything in between, we have two two options, right? But there is one thing that I'm taking for twice. This thing, this complete thing. See, for here, you can have a prefix also and suffix also. But for if you're starting from very this place, you don't have a prefix. The prefix is of size 0, right? And same way here also. If you are at this ending place, there is no suffix. Like if you are at one place before, then you have a suffix. So you cannot add for both of these twice. Is it making sense? Yes, no? So here for each of the elements in between, I have done 2 times all the elements. Like for each, you have 2 options. No, you don't have for each of those. Why? Because for the first element, there is no prefix. For the last element, there is no suffix in this range. So that's why here it is 1 less. So overall, it will be n minus 1 into 2 or 2 into n minus 2. Is it clear? What about others? Everything else is same. Like I just remembered this when I like saw that thing. Yeah. So I hope this is like clear. If not, like just ask me in a query, like I'll explain this again in case like there is any doubt. So thanks for joining. Bye bye.